Hi, I'm Yao. You're about to learn about different types of reactions from Olivia, Jack, Kayla, and Marcus.
In sports today, aluminum and calcium traded sulfate and hydroxide to form two new teams, aluminum hydroxide and calcium sulfate. This circumstance is better known as a double replacement reaction.
Team Copper 2 Sulfate got into an argument. So Sulfate decided to fire Copper and replace him with Iron, who will now be the new head coach. Also, the team will now be called Iron 2 Sulfate. This can also be called a single replacement reaction. Back to Timmy, for breaking news.
Did you know that color change, temperature change, production of solid precipitation, and charge and odor lead to evidence of chemical change? Now for celebrity gossip.
Iron and oxygen met on the slide, fell in love, and produced iron oxide. Also, antimony and iodine met on the monkey bars and produced antimony iodide. It was awesome. These types of reactions are called synthesis reactions.
On a less happy note, the old cup of water, better known as H2O, grew apart and are single and are called hydrogen and oxygen. And A and Cl broke up and are no longer salt.
The sugar factory just blew up. In the presence of oxygen, the combustion of the factory produced H2O and CO2.
We've been walking around the streets, and we're here with Charlotte Despard.
Charlotte, what do you think this means?
Zoom in. 2 lines.
2 lines.
2 lines. You're close. It is 2 lines, but it also has another meaning. It separates the reactants and products being added. So, say you're adding oxygen to iron, it would separate the two. Do you understand? Sweet. We've been walking all over the streets looking for people to ask questions, and we just couldn't find anybody. So we're back here with Charlotte.
Charlotte, do you know what this means?
You.
It kind of does mean her because it's pointing at her. I see where you're coming from, but then I turned 5. But really, it means that something yields or produces something else. So say you had H2 plus O, it would yield H2O, or water. Do you understand, Charlotte?
Charlotte, do you have any idea what this means?
A triangle on top of an arrow pointing to you.
Close guess.
That's close. I understand that. But really, it means heat has been added to the reaction. You understand?
Charlotte, do you know what this means? Any guesses?
Something cold added to you.
Could be.
It could be. Why don't you tell her what it means, Kayla? That means Kayla doesn't know either. She's in the class. It really means a catalyst has been added. So MnO2 in this reaction would be the catalyst. Do you understand, Charlotte?
And the last one, do you know what this one means?
Train track.
Train track. It could mean a train track. There are lots of trains around here. But really, it means it's a reversible reaction. So the reaction could take place either way. You understand? Great. I think that's it.
I'm walking the streets of Katy, Texas, asking people questions about chemistry. Here we have, what's your name? Nancy? We have Nancy, and I'm going to ask her some questions. Nancy, what is the law of conservation of matter? Not quite. The actual answer is the law of conservation of matter says that matter cannot be created nor destroyed.
This is a skeletal equation. Skeletal equations are equations that are unbalanced. So, to balance it, I'm going to swing it over to Jack to balance it.
I'm here to show you how to balance a skeletal equation. Tight. You could call me an expert at balancing skeletal equations. I've balanced a few in my lifetime. The first step is drawing a line down the middle, right where this arrow is. The second step is to write out your elements involved in the reaction. So in this case we have sodium, Na, and O, oxygen. So we write them both on both sides. The second step, or the third step, was that the third step? I think that's the third step, is to write the amount of atoms of each element over here. So on the left side of the arrow we have 1 sodium atom and 2 oxygen atoms, hence the 2. On this side we have 2 sodium atoms and 1 oxygen atom. Now we need to balance it out and get the same amount of each element on both sides. So to do that, this 1 here needs to be a 2. And to make this 1 a 2, we have to multiply this side by 2. Multiplying this side by 2 changes the 1 oxygen to 2 oxygens, but also changes the 2 NAs to 4 NAs. Now this side we're balanced. We have 2 O's on each side. Now we just have to get 4 NAs on the left side. To do this, we multiply Na by 4. Just like that, we have a balanced skeletal equation. This has been all for the Cinco Ranch Chemistry News. Stay classy, you guys.